people can see this. If you can't see the YouTube live, go on TikTok. Let's see. Hopefully people can see this on YouTube. Oh man, it's backwards. Dang. All right. Okay. The YouTube live is backwards. All right, let me see if I have another thing. All right, cool. So let's talk with the parallelogram. So this person asked the question of finding the area of this parallelogram right here. So what is it? Is this is the shape of the parallelogram. 5. Let me see who's smart. How would you guys do it? Let's see who can remember geometry. How would you find the area of this parallelogram right here? 3 is here, 5 is here, 7 is here, and so this whole thing is 7. So that one is 3. That one is 5. This is 3, and then so that means if that's 7 here, that's 4. Okay, so how would you guys find the area of the parallelogram? So who can? Let me see who got an answer for me. Let me see. Let's see. I have 43 messages. Can I teach isomorphism? This person seems like he's asking a bunch of random questions. Can you teach isomorphism? What class are you in? Name UIEOP. Do I think they're gonna cancel ACT this year? I don't know. I heard some speculation they might do them on like online, where you take the test on the computer at home, and you have somebody watching over you. I've heard those speculations, but I don't know. I really wouldn't know because nobody really knows what's going on in this with COVID-19 and stuff. Okay. All right. What grade do you teach? I don't teach. I tutor kids privately. I don't teach at any schools at all. And place it. Isabel _19. All right. So, okay. Anybody has the answer to her question about the parallelogram? It's sine, cosine, and tangent stuff. Okay, I'll write that down and do a little bit of that. Okay, so, all right. So, in order for us to find the area of this parallelogram, we know the area of the parallelogram is kind of like a rectangle. Base times height. So how do we find the area of the parallelogram? So in the hint, it asks us to find the area. So what we want to do here is find the height. The height of this parallelogram here is what? And it's h. So we have base. The base is 7. So this, the length here is the same length here, 7. So the base is 7, and we just need the height. The height is what? So we got the base, which is 7, and we just need the height to multiply the 7 by the height by the base to find the area. So how do we find the height? So we have this is 5, this is 3, and h. So what you want to do is h squared. You're going to use Pythagorean theorem to find h, the height here. So what you're going to do is h squared is equal to 5 squared minus 3 squared. Another way to think about that is saying that the hypotenuse squared, 5 squared, is equal to the length of the other two sides squared, the other two legs squared, 3 squared plus h squared. So you subtract 3 squared from both sides, minus 3 squared. I'll do it this way so you guys can understand. Minus 3 squared, 5 squared minus 3 squared is equal to, so this 3 squared is cancel, is h squared. The same thing we started here, right here. Just a couple steps so you guys can understand. Let me know if you got it so far. Let's see. We got the answer what h is going to be. Let's see who says what H gonna be. Can you do special right triangle, 30, 60, 90 triangle? I posted a video about that. I'll do some of that. 30, 60, 90 triangle, sine, cosine, and tangent. 30, 60, 90. I just posted a video about that, I think today. Sine, cosine, and tangent. All right. If you got more questions, keep them coming. So what's H gonna be? Who got the answer to H? All right, 16. Allison says 16. That would be H squared. 4. Yeah, just saying. That's who got the answer. So yeah. So 4. So that's what the volume of H is. So H is, so what we have here is what? 25. What's 3 squared? 9 is equal to H squared. So that means 16 is equal to H squared. So that implies that H is equal to 4. We could say plus or minus 4, but you also know that this cannot be about negative. So H is equal to 4. So that's it. So the value of H is 4. 7 times 4, and that's how you find the area of the parallelogram. You have the base, the height is 4, so 7 times 4 will give you the area of the parallelogram. That's it. That's how you would solve for this one. So this is one of the questions that we get. So you guys can tell me what the area is, I think. Yes, no, maybe. Let's see. Can you find the area of the parallelogram? Yeah, somebody say 28. I think that's what I would get in this case. So yeah. So whoever asked the question, let me know if you understand. And if any of you guys don't understand that too, if you're taking geometry or you don't understand that, let me know too, so I can go through it again. Let's see. Okay. All right. It looks like everyone understand. Okay. Let's move on to something else. So the person who asked the question about the rational functions. Are you still here? Rational function question. Are you still here? Yes, you understand. Now, thank you so much. No problem. Rational function. Are you still here? Yes. Is it King Ace? Is that the one who asked about the rational function? Please answer my question. My homework. Do at midnight tonight. What you got? What you got in your homework? I wish you would have sent it to me. All right, King Ace. This is what you want to do. I don't remember what let's see. King Ace, this is what you're gonna do. And it's a bummer that the YouTube live is showing this way. Showing backwards. Okay, King Ace, this is what you want to do in this case. So here's what you have. You have I need a black marker. You don't know how much I go through these markers. I just would have said like less than a week ago. All right, cool. So this is the x-axis. This is the y-axis. So what we're solving here is we have the graph of a rational function. We want to know what equation corresponds to that rational function. What you're looking at right here, that's what we have. So we have the graph of the rational function. We want to know what equation corresponds to it. So first of all, we're going to graph it the same way they give it to you. So in your graph, and the graph that I saw in what you sent me via text, it looks like my graph is terrible. So downward here, you have something going this way, something going that way. All right, so that's what you have. And then, so this would be your asymptote, vertical asymptote at -3. And there's another one at -3 again, at +3, sorry, at 3. But you also have two pieces of the function, one of them here. So there's also a vertical asymptote at 1. Let's take this color. It's also a vertical asymptote at 1. And then on top of that vertical asymptote, you have one piece of the function going this way, one piece of the function going this way. King Ace, I think that's what you have, right? Look at your problem. I know I'll take a screenshot of it, but I don't think I have it here with me. King Ace, that looks right? Yes, no, maybe? Okay. I'm not seeing any comments. I guess that's right. I think that's what I have. Okay, so the way you would solve for this is, the way we normally solve for those, and if you guys having trouble seeing me or hearing me, let me know too. The way you normally solve for those, when you're solving for this, the way you would solve for it is saying, okay, I need the equation. So I don't know what the equation look like. I know it's a rational function, so it's something. It is something over something else. So it's going to be a function divided by another function, f of x, divided by a function g of x. So that's what we want to know. So I think some of the choices they give you is x squared minus 9, and there was x squared on top of it. I think that's one of them. The other choices were x squared minus 9, 3x squared minus 9. That was one of the choices, one of the other choices, and I think it was 4 of them. And there was one that had x squared minus 3, 3x squared. I think that's what you had, x squared minus 3. I think that's what you had. So when you're looking at this, it's saying we have 2 vertical asymptotes. So that means we have two numbers that makes the denominator equal to 0. So that means the domain has two restrictions, one right here, one right here. So that means we need to find a function when you find a function that has 2 zeros, one at 3, one at -3. And then if you're looking for a function like that, with 2 zeros, one at 3, one at -3, so the function that has that is x squared minus 9. So when you do x squared minus 9 is equal to 0, so that means x plus 3 is equal to times x minus 3 is equal to 0. So one root is x equal to 3. The other root is x equal to -3. So the vertical asymptote, they'll give you the roots. So they'll give you the roots, the part of the function that when you plug it into the domain, you don't get an answer for it. That's undefined. So these two will give you the roots. So that means we need at the bottom x squared minus 9. So these two are gone. That's why I wrote them last two. I know they were gone. So we're not going to deal with these two. So I don't know whichever choices they were. The ones that had the 3 at the denominator, they're not answers. So now we know the original asymptote is at 1. So that means in order for you to find the original asymptote, so what you want to do is think about when x is really, really, really big, what are these functions going to look like when x get really, really big? I say x is 1,000. So when x is 1,000, that 9 won't even matter. So what you're basically going to have is x squared divided by x squared. When x is 1,000 here, that other 9 is not going to matter. So what's going to happen is it's like you're going to have 3x squared divided by 3x squared. So when as x goes to infinity, which is what's happening here, as x goes to positive and negative infinity, the function is going to convert. In this case, is going to have a value of x squared divided by x squared, which is 1. In that case, it's going to have 3x squared divided by 3x squared, which is 3. So look at the horizontal asymptote. Does it say 1 or 3? In your case, I believe it was at 1. So if it was at 1, you pick the function where whenever x get really, really big, the function is going to converge into 3, because that's what it does, because this goes all the way out to positive infinity. And it never touches 1. So if you go inside of the function, if you didn't know, let's say you know the bottom piece, if you didn't know, plug in big values inside of this and inside of this. You're going to see when you plug them inside of the second function, it's going to give you values that are closer and closer and closer to 3, which is asymptote higher than 1, 1, 2, 3. if you plug in inside of this function, it's going to give you values that are closer and closer to 1. Ace, king ace, let me know if that makes sense. Let me see if you have any questions. Does that make any sense at all? King ace, going once. He's probably not even here. King ace. Not make any sense at all. Are you gone? Let's see. I understand it. I appreciate it. Thank you. No problem, man. All right. So high 39. Can you choose when to plug it in? I'm not sure what you're saying. Can you choose when to plug it in? High 39. I'm not sure what you're saying. Okay, Ken Ace, I appreciate you being here, man. Yeah, I'm glad you understand. If you have any questions, let me know, because that's something that people confuse with sometimes. The original asymptote, these will tell you, hey, if I plug these in the denominator, I should get 0. So that gives you, x plus 3, x minus 3. So these are the terms that makes this equal to 0. But the vertical asymptote, the way you find the original asymptote, the way you find that one is saying, okay, as the function, in this case, as the function going to positive infinity or negative infinity, what is, as x values goes to positive infinity and negative infinity, what is the function values converge to? So in this case, it's going to 1. If it was going to 3, you would have a higher asymptote. And that's what it's saying. It's saying that, hey, when I get plugging big and big and big values into this, it's gonna get all the way out this way and that way. It's gonna go to 1. So that's what gives you the horizontal asymptote. And the vertical asymptote, you get that straight from the denominator. All right, cool. Let's move on to something else. I think we can do inequalities, system of equations, the sines, 30, 60, 90 triangle. Let's do that. Any questions? Yes, no, maybe? All right, let's do 30, 60, 90 triangles. I've done some of these before, and I think it's kind of straightforward. I have a longer video on my phone. I haven't put it anywhere yet, but I uploaded a short video today. So 30, 60, 90 triangles. So 30, 60, 90 triangles. So as the name says, it's 30 here, 60, and 90 triangles. All right, cool. So think about this. This angle is 30 degrees. This is 90. And this angle is 60 degrees. Okay. All right. So now what does that say about these angles? So the sum of them add up to 180 degrees. That means we have a triangle. But also, because that's a 90-degree angle, we have a right triangle. In other words, you can apply the Pythagorean theorem to find the length of one side. If you have two sides, you'll find the length of the third one. But in a special case of a 30, 60, 90 triangle, because we know that, we can have one side here. If we have the length of one side here, let's say this is 5, we can find the length of all the other side easily. So here's how it goes. The side that is opposite to the 30 degrees is the smallest side. And I'll kind of show you what's happening. So let's say, think about you are opening this at a 30-degree angle. So if I'm opening this at 30-degree angle, if I have those same length, I'm opening them at the 60-degree angle. This is going to be shorter than this. If that makes any sense at all. If you don't understand what I'm saying by this is, so because these lengths are the same, they're saying the same. So this open at the 30-degree angle versus opening for 60 degree, that makes this length bigger than this one. That's how I remember it. So the side that's opposite to the 30-degree is the smallest one. So this one is the smallest one. And the one that's right here is the hypotenuse. That's the biggest one. And then the one that's right here is what comes after the smallest one. So the middle one. So now, if I have the smallest one, I can find this one and I can find this one. When you were in a right triangle, you would need two sides to find the third one, unless you do some trig stuff. But in this case, I only need one side because I have a 30, 60, 90 triangle. So in order for me to get this side, so this side would be 5, that length, multiplied by square root of 3. And then the hypotenuse would be 5 multiplied by 2, which is 10. And that's it. That's all you need to do for this one. That's 5 multiplied by the square root of 3 to get the middle side. And then 5 multiplied by 2 to get the biggest side. How do we verify this? Okay, let's verify. So it's a right triangle. It satisfies the Pythagorean theorem. So that means 5 squared plus 5 square root of 3 squared. That should give me 10 squared. What is it, right? So I square this guy, the hypotenuse. I square these two. Let's see if they are the same. So 5 squared is 25. 5 square root of 3 is what? 25 times square root of 3 squared. Square root of 3 squared is 3, right? Let's go to 10 squared. So 25 times 3 is equal to 10 squared, right? 25 times 3 is 75. So 25 plus 75, what's 10 squared is 100. So 100 is equal to 100. So that means we prove that if we have a 30, 60, 90 triangle, if that side is 5, this is 5 squared root of 3, and this is 2 times 5. Now, do you understand? And if you don't, I will help you. Do you guys understand? Yes, no, maybe? Oh man, my phone is at 20% again. I gotta charge this. It's too early for this to happen. All right, you guys understand? Let's see. Do you understand? Hold on. It's too early. Let me charge this. Oh man. Do you guys understand what I did with 30, 60, 90 triangle? Do you understand? Yes, no, maybe? Any questions? Shit, I'm gonna have to plug this somewhere else. Oh, plug it at all. Any questions on the 30, 60, 90 triangle? Okay, somebody say yes. All right, let's see. Any questions? Let's see. Trying to set this up right. Uh-oh. Let me see if you guys have any questions on the 30, 60, 90 triangle. All right. So I don't see any questions at all. Let's see. How many live stream will you be doing? I do them every Tuesday at the same time, about 10:45, 10 o'clock. So every Tuesday, that's when I do them. Okay. Yes, that means yes, you understand. Can you do secant, cosecant, cotangent? Can you literally give you a question for it? Okay. I'm gonna try to explain it something. Remind me when I get to the drill trig stuff so I can explain it. Oh, makes sense. Okay. Thank you. I appreciate you. Alon, I appreciate you. Well, I'm glad I can help. Let's see. I don't see any questions. Let's see. If you send it to me, I probably won't be able to solve it until next Tuesday, because I would have to look at it, and I can't do that while I'm live. Molar mass is easy. Okay. Inequalities. Okay, I'll do inequalities now. Yeah, if you have questions about cosecant, cotangent, molar mass. Is that chemistry? Let's see. You're doing great. Thank you. All right. See, I don't see anything else. If I knew what. When he cuts out and he is the made of reading the comments. Okay. All right. Any other okay. I don't see any other questions. All right, cool. So, all right, guys. Yeah, I was trying to read your comments. Thank you for the person who's trying to help me. All right, I'm glad you understand this. So the other way to think about this too, if you had, let's say you know the side, the same question can be asked a different way. So let's say you know the hypotenuse. So if you know the hypotenuse, let's say you know the hypotenuse to be 17, for example, random tricky number. So let's choose 18 to make this look nicer. Let's say you know the hypotenuse to be 18. So from the hypotenuse, so what you can find this side, because you know the hypotenuse is, this side is the hypotenuse divided by 2. You get 18 divided by 2, which is 9. And then from this side, you get this, which is 9 square root of 3. So the key side normally is this, the smallest one, the one opposite to the 30-degree angle. So it's easy. And then if you verify those, you should get this square plus this square is equal to this square. Other thing too, let's say if I have this side, so anytime you have this side, let's say if I knew this side to be 600, if I want this side, so I'm going to do 600 divided by a square root of 3, because from this to here is whatever I had here multiplied by square root of 3. So from this side, whatever side you have, trying to go back to the smaller one, because it's easy. Because if I'm going from here to here, it's a different relationship. You know, from here to here, I know I divide by square root of 3, and then from here, I multiply whatever I had by 2. So try to always go back to the smaller side of the triangle, which is the one opposite to the 30-degree angle. I hope that makes sense, and if it doesn't, we can do something else. All right, cool. Let's do something different. Let's do inequalities. Somebody asked about inequalities. So let's say I had 5x plus 3y. 5x plus 3. 5x plus 3 is equal to x minus 4. All right, let's see if I can solve this. So greater than x minus 4. So let's see if we can find less than actually x minus 4. So let's see if we can solve for this inequality. So inequality and equality, like it's basically almost the same thing up until the point you get to the end. That's when you have to say, okay, do I need to flip the sign? Do I need to leave the sign the same way it is? All right, so let's see. So when you would solve this, you would try to get everything that has x on one side of the equality, and then everything that doesn't have x, you would try to get it on the other side. So the 5x plus 3, x minus 4. So what you would do is 5x plus 3. So what you would do, so you can add 4 to both sides, add 4. So that would give you 5x plus 3 plus 4. Actually, not x, not 4. Subtract x from both sides. Let's subtract x from both sides. Negative x, right? So I have 5x minus x plus 3 less than, this x here is canceled because negative x was here plus an x minus 4. This is canceled, this is gone. So now I'm going to find a way to put this 3 this way. So what you do is, so 5x, I'm going to write it, I'm going to do it step by step. I won't even solve anything. It's less than or equal to, so actually minus 3. So I subtract 3 from both sides, just like I subtract x from both sides in the first step. Second step, I subtract 3 from both sides. So I have 5x minus x. 3 minus 3 is gone, it's 0. So now I have minus 4 minus 3 is minus 7. Cool. All right. So now, what did I have here? 4x less than negative 7. Here's how you would solve for this, even if you had equality, it's the same thing. 4x is equal to 7. Kind of like this same thing, you divide both sides by 4, so you divide this guy by 4, and you divide this guy by 4. This 4 cancel, x is less than negative 7 over 4. So now, what you would do is you would go to the number line, and then graph this, 0, negative 1, negative 2, 1, 2. So, in order for you to graph this, you would say less, so what is negative 7? What is 7 over 4? Negative 7 over 4 in terms of number. Let's see. Let me get my calculator, 1 second. All right, so negative 7 over 4, 7 divided by 4, 1.75. Okay, oh. All right, 1.75, let me see. Got this in pink. Negative 1.75, so it's between negative 1, negative 1.5, negative 1.75, less than. I'm gonna put this graph a little bit somewhere where this can be meaningful to you. Hold on. Erase this. So, here's the graph. Let's put 0 here. Negative 1, negative 2, negative 3, negative 4, because I know I want these 0 and stuff. So, what's the graph said? It says x is equal to negative 7.5. So, negative 7.5 is between negative 1 and negative 2, and it's closer to negative 2, it's right here. So, I know as x is less than those numbers. So, x, so if I have anything less than those, the negative 7.5 is part of the solution. So I can go this way. I cannot go this way. And I go this way. Anything that's less than negative 7.5. That's what it says here. X is less than negative 7.5. So anything that's to the left of that, that's part of the solution. Now, what do we put here? A circle, a closed, or open circle? Let me see who has the answer. Hold up. And then let me see if you have any questions, ask them too. All right, so why is it taking my dad? I know, why is it taking him 13 years to come back? Okay, so live 1 mile away from the gas station. I actually thought about making a video about this. All right, cool. Who has the answer to this? Oh, I almost sent a message to someone. What is this doing? Shoot. Let's see. So who has the answer? What would be a circle? Okay, so now the way you think about this is it's either going to be a closed, open circle. Oh, somebody said open circle. Or he just said a circle. Let's see. Is that a closed circle or open circle? Turn on open circle. All right. So someone said open circle. So why is it an open circle? So when you think about open, it's strictly less than or strictly greater than that value. So yeah, it is an open circle. So it's going to be open circle at this point right here. So when you have an open circle, that means you have a strictly less than or strictly greater than. But if you have a less than or equal to, is a closed circle. So the way you kind of think about it is just like it's open. That value is not included in it. But if you close it, that value is included in it. That means you have a less than or equal to or greater than or equal to if you were going on this side. So in this case, it's an open circle. So yeah, that's how you solve for inequalities. Let me do another example where you have Let me do another example that is a little bit different from this. So let's say I have 3x, negative 3x plus 2 is equal to x plus 1. So simple, right? Less than or equal to. Less than or equal to x plus 1. So simple. You start out the same way. So what we're going to do here is add, I'm going to subtract 2 from both sides, minus 2, right? So subtract from both sides, negative 3x, minus 2 is gone. So here, minus 2. I should have brought the x first. Minus 2 plus 1 plus x. Now I'm going to move the x on that side. So what I do is subtract x from both sides. Minus x. Less than or equal to, minus x and then minus x. So I'm subtracting x from both sides. Minus 3x minus x less than or equal to negative 2 plus 1. X minus x is gone. Okay, so negative 2 plus 1 is negative 1. That's the negative 1. Negative 3x minus x is negative 4x. Okay, now who can tell me what x is equal to? Let's see. Let's see who's fast. What is x equal to? Let's see. Anybody has the answer to x? What's the value of x? No? Yes? Maybe? Somebody say that on. Yeah, this is a brand new problem. What's the value of x? Who has it? Okay, who's confused? Amanda the fave. Okay, what you confused by, Amanda? Because this is a new problem. Okay, somebody says 12, negative 1. Okay, let's see. All right, so the value of x is negative 4. So you divide both sides by negative 4. So now, here's what's tricky about this is when you divide by a negative number, what you have to do, you have to flip the sign this way. Negative 4. Okay. So you divide both sides by a negative 4, that means x is equal to 1 over 4. Not equal to. Greater than. I started with less than. Greater than 1 over 4. So when you divide by a negative number, this may seem confusing. Let's see. Can you see the board? Yeah. So when you divide by a negative number, what you have to do is flip the sign for this. So it was less than. As soon as I divide by a negative 4, which is a negative number, I went from less than to greater than. Less than or equal to greater than or equal to. So x is greater than or equal to 1 over 4. So what you do here is, let's say you have 0, 1, 2. So 1 over 4 is 0.25. 0.25 is somewhere here, right? So it says greater than or equal to 1 over 4. So that means everything to the right. Greater than or equal to it. So now, do we have a closed or open circle? Let's see who is with me. Do we have a closed circle or open circle? Okay, so someone says 25. Jack Stang meme 25. Carlos Mendina say 50. That's on YouTube, guys. All right, cool. Let's see. Someone say this is sake. Appreciate it. Spotify stuff. All right, so closed. Somebody said a closed circle. Okay, 2 people said a closed circle. Amanda, you said you didn't understand something. You were confused. Let me know what you were confused about, because this is a brand new problem. I haven't. You haven't been doing math for 5 months. Yeah. So x is greater than or equal to 1 over 4. Good job, Sarah. Yeah, you're probably the only person who answered it here. You can make sense and You're very helpful. Thank you very much. I appreciate your help. Appreciate it. All right, so it's actually a closed circle. So closed means it's going to be part of it too. So this is part of the solution. Opens mean it's not going to be part of it. So that's why we have closed for greater than or equal to or less than or equal to. It's going to be a closed circle. So that's what we have. So I did 2 examples of inequality. So basically, you solve them like inequality. When you get all the way to the bottom, you find out if you need a closed circle or open circle. So that's all it is. Hey, you get all the way to the bottom, find out if I need a closed circle or open circle. If I have a negative in front of the x, to get rid of that negative, I'm going to divide or multiply by a negative number. So what's going to happen is I'm going to have to flip the sign. That's the only difference between that and equality. So all the way almost to the bottom, you do everything the same. So you're going to see if you flip the sign or don't flip the sign. And the way you write the solution is this. So there's other ways you can write the solution. So we can write the solution in interval notation. So here's how you think about it. Think about, okay, let's say I'm starting all the way from the left. What are all the things that are part of the solution? So I'm starting here. So this is what? 1/4. And then it goes all the way out to infinity. So I just put it this way. Now, do I have this here or a bracket? Do I have a parenthesis or a bracket? Which one of them do I have in this case when I'm writing the solution that way? Do I have a parenthesis or a bracket? Let me see who has the answer. Let's move on quick because we're going to do something else. Let's see. Oops. I think I messed this up for y'all. Parenthesis or bracket? Who has the solution? I don't see it. Let's see. Anybody on YouTube insert? No. Parenthesis or bracket? No. I don't see any answer on YouTube. So what's the answer? Parenthesis or bracket? Okay, somebody said bracket. Yeah, who said bracket? Sarah. Sarah, you've been doing good. You probably took this class already. You got here flexing. All right, so it's a bracket. Yeah, so bracket means just like the same, just like the closed circle. Bracket means include that in there. Parentheses means you don't include it. If you think about it, infinity, you never reach that. You never include it in there. And here you have a bracket. So if the solution is that way, that's how you write it. So you start with this all the way out to infinity. And the solution that we had before, if you wanted to write it, let me erase this so I don't confuse you. Before, when we had the solution of, what was it, -7, it was negative, x was what? Less than negative 0.75 or 1.75. I think that's what it was. So 0, -1, -2. So 1.75 is somewhere here. So how would you write the solution? The solution was, an open circle going all the way out here. So when you're writing the solution, you start from left to right. So from left, the first value I'm going to hit that's part of the solution is -infinity. And I'm going all the way to right. I'm going to have what? -1.75. That's a bracket for the solution before. Is that a bracket or a parenthesis? Sarah, I know you got this. Let's see who got this first before Sarah. Is that a parenthesis or a bracket? Let's see. Nobody? No one? All right. Is that a parenthesis or a bracket? This one right there. So you thinking about this solution. Let's see. Somebody said a bracket. Cammy, bracket. Remember, x is less than. Can you explain what a log is? Okay, we'll do some log function. And ln. Okay. We'll do some log function. Actually, we'll go into that. Yeah, parentheses. Sarah got it. Yeah, so it can't be a bracket because if you have a bracket, that means include the solution in there. So in this case, what we're doing is a parenthesis. So, and the one that was right here that was greater than or equal to is a bracket. But that one is a parenthesis, which is strictly less than. Strictly less than, strictly greater than, you have an open circle and you also have a parenthesis in the solution. But less than or greater than, you have a closed circle and you also have a bracket. All right, cool. Let's do some, we can do logs, trig, system of equations. All right, cool. With the 30, 60, 90 triangle, somebody say talk about log. Okay, so let's talk about the log function. So, and ln. So they call this one the natural log. And this is, the logarithmic function, the log function. That's what they do. So, big fact. Does any calculator that you have, they don't do, if you see a log on it, they don't do the log the way you think of it. So like if I say log 4 on this calculator, what it's going to give me is log by default, it's going to give me log base 10 of 4. So that's the big thing that most people don't know. And then the ln is log base e. So let's start. For the log, it's basically a reverse operation kind of to the exponent. So if you think about it, like when you have x squared, if you're thinking about doing the reverse operation of that, you do the square root of that. So square root of x and x squared, one of them is the reverse operation of the other one. So that's what the exponent is. So like, let's say I have 2 to the x, like we have 2 to the x. So if you want a reverse operation of it, it's kind of like having a log function. So the log function, the way you work with it is knowing all the properties of log. So the first property is if I have a log base x of a plus the log base x of b, and this is how you read them. Before I go on the property, I'll do the properties. So the log base x of a log, the way you read them is log. Some people might say log x of a, but it's normally log base x of a. Here, log base x of b. So the first property is log base x of a plus log base x of b is equal to the log base x of ab. So it's similar to what you have here when you have exponent 2 to the x, 2 to the a. Let's say you have x to the a multiplied by x to the b is equal to x to the a plus b. It's kind of like the reverse of that because you see every time here you had these first two, you had the multiplication turned into addition. You have the addition turned into multiplication. If you can think about it that way, in terms of being a reverse operation of the other one, you'll understand what I mean. All right, so these are properties. So those are things that you'll find in the book, you'll understand, and then you can memorize too. So by the same token, log base x of a minus log base x of b is equal to log base x of log base x of a over b. Right? So it's kind of like having, x to the a divided by x to the b is equal to x to the a minus b. So think of a minus reverse operation. Wherever the multiplication division was, the subtraction replaced it. Wherever the subtraction was, the division replaced it. Think about it as reverse operation. So that's for the log. The other thing that's cool and neat, and that's the one we use mostly when we have these calculators, is log base x of a. So this is what you call the change in base. So what I can do here is replace, get a random base. Crazy stuff. You can get a random base and say log base, a random base, let me call that base b, of a divided by log base b of x. The change of base is what I'm doing is I had log base x of a. So if I can do that, I can find a random base. I put it in the numerator and denominator, and then I put this up top, and I put this one up top, at the bottom. It's kind of a weird way to explain a property, but if you remember those, you'll be able to solve for them. So application of these is solving equations, and I'll show you how to do the last one. I'll show you a little bit about it in a calculator. So actually, let's do it. So if I have log, so if I want to know log base 5 of 4, this you can't do it in a calculator like that with whatever they show you here. So what you have to do is, let me see if y'all understand so far. You guys understand? Let me see if you guys understand. Do you understand? See who has questions. Okay. You understand? Yes, no, maybe. What does the 2 mean? What 2? What 2 are you referring to? Okay. All right, so I'm going over the log. Do you guys understand? Yes, thank you. Okay. I thought you said yes, thank you. Kind of. Okay, kind of is me. I don't understand. All right, kind of is I don't understand. So these are properties. The only thing is just to remember them. So this, what I was showing here is, if I want to find a log base 5 of 4, because on the calculator, I can't put it in there. So what I have to do is saying, using this property right here, the 4 is here, the 5 is here. So what I'm going to do is saying the one that's in the calculator is log base 10. Even if you don't see the 10, is log base 10. So what I'm going to do is log base 10 of 4. So I do the top part, which is base b. I replace, what if I have a random base b, a random base b, and go 10 in this case, log base 10 of 4 divided by log base 10 of 5. So whatever is at the bottom was at the bottom is at the bottom. So this one, without being able to do it in the calculator, I can find it. Without being able to plug it in directly in the calculator, I can find it. So let me give you application of those, because this might confuse you. Let's give you some stuff that you can take with you. So it's in the solving stuff. That thing I just wrote on the board, you can find it in the book. It's not that complicated. So let's say I have log base x of 3 is equal to 27. Okay. So who can solve for this? Who can solve for this? Let me see what you would do to solve for this. Let me see. How would you guys solve for this? Log base x of 3. What's the value of x? That's what I meant. How would you solve for this? Oh, if I flip them around to make them easier for you, that's probably better. 27 is equal to actually 9. So you can see the difference. Is equal to 3. So log base x of 9 is equal to 3. So what's the value of x? Log base x of would you divide by 3? No. No, it's kind of like don't. No. All right, log base x of 9 is equal to 3. Okay, let me show you what it asks, and then you can find the other ones when you're doing it. Okay, so what it's saying is, at a base of x, what number when I raise it, I didn't give you guys a number that I was hoping to give you. Okay, so the base is x. Let's do 2. I'm trying to give you guys some good numbers. Okay. So log base x of 9 is equal to 2. So the base of x, when I raise x to the power of this guy, I get what? So when I raise x to the power of this guy, so what do I get? So let's see. So can you solve for x based off of what I just gave you? Let's see. And we'll do a bunch of other ones so you can understand. And I'll explain it to you. Can you guys solve for x based on what I just gave you? Solve for x based on what's on the board. Let's see. What's x? Anybody? Let's see. No, not divided by 3. Somebody say 11 times 0. Okay, I'm gonna get 9, so that means x has to be 3. Yes. Yeah. So x3. So 9. So what you do is you say, hey, take the square root of both sides. Square root of x squared, square root of 9. And of course, we're using a positive root. X is equal to 3. Okay, so now let's show you. Let me show you guys what happened. The way you think about this is saying what I thought about it, and we're gonna do another one. So I say at a base of x raised to the power of whatever is on the opposite side, raised to the power of whatever on the opposite side, which is 2, what that equals to 9. So the base is always x, the base, raised to the power of whatever is on the opposite side. What number x, when I raise it to the power of whatever is on the opposite side of equality, that I get 9. What number x here, base, what number x as the base, when I raise it to the power of whatever is on the opposite side, I get 9. So x to the power of whatever is on the opposite side, I get 9. So of course you know that's 3. Somebody inserted. I didn't catch your name, but I know somebody inserted. So let's do another one. So let's say I have log base 5. Trying to give y'all numbers that I know is gonna work. All right. Log base 5, and that's the number that I was thinking to. 565 is equal to x. Who can solve for this? So log base 5 of 565 is equal to x. Actually, that's just solving this in the calculator. Let's see. That's just solving this in the calculator. The way you would do it is just say, so x is equal to 4. That's not what I meant to do. I meant to write this somewhere else. Okay. Log base 9. Log base x of 81 is equal to 9. So what x? What is x? Is equal to 2. Log base x of 81 is equal to 2. So what's the value of x? Let's see. Who got the value of x? Log base x of 81 is equal to 2. What's the value of x? 9. Sophia Z say 9. So Fees says 9. Who else? Who else got an answer? Yeah. So what it really is log. So what it says here is, that's my alarm. Hold up, y'all. Cancel. My bad, y'all. All right, that was my alarm. I don't know if you heard that. So what it really means is saying that at a base of x, raised to the power of whatever is on the opposite side, or do I get 81? So x squared is equal to 81. X is equal to plus or minus 9, but for log, you take the positive side, which is 9. The way you would solve that in the calculator is to check yourself. I could go in the calculator and put log 81 base 10 divided by log, and that's the third property, change in base. Base 10 of what x was, 9. And that should give you 2. Let's see. If not, I didn't do it right. All right, cool. Log base 10 is already put in the calculator, divided by log base 10 of 9. And that should give me 2. And that's what? That's right. That does give me 2. So, man, that was good. So, what you solve for those is saying, does x, whatever is here is going to be the base, it's going to be raised to the power of whatever is in the opposite side, and then I get 81. So, I get whatever is in front of the log. And that's basically it. Any other questions specifically about log? I think 9. Yeah, somebody solved for it. 81 divided by 2, no, Mira. 9 was the answer. Mira on YouTube, 9 was the answer. Mira _20, 9 was the answer for that. All right, cool. Can you see the board? Not backward. I don't know if you're seeing it backward. Mirror on YouTube. I'm not sure if you see the board backward or not. All right, cool. Let's see. Oh, stop. I made this blurry. Can y'all see this clearly? Let's see. All right, cool. All right. So any questions? Questions. Let's see. So some stuff about the properties. So I can use numbers on them. So if I had log, there's another property too. Base 2 of 4 plus log base 2 of 8. So that would equal to log base 2 of what? Who can tell me what that is? Log base 2 of 4 divided by log base 2 of 8 multiplied by log base 2 of 8. That would equal to what? Log base 2 of what? All right, let's see. Thank you very much, Mira. Mira _20. Uh, yeah, I'm sorry that you had to go through a board that's upside down. I mean, that's not showing right. But thank you for your support. I'm gonna try to see if I can get this correct because I'm doing this live on the computer. Thank you for your support. Let's see. So who got the answer to this? Log base 2 of 4 plus log base 2 of 8. That's log base 2 of what? What number I should put here? According to the property that we saw earlier. What number I should put here? Let's see. Who got the answer? Log base 2 of 4 plus log base 2 of 8. So the input of log is positive, but if you have a log of a small, like a really small number, you can have a negative number. So, but the input, the value, the x value of log is positive. So whatever you put in is positive. But if you have a log of a number that's like really small, the output can be negative, but the input cannot be positive. Is only positive. If that makes sense. So whatever you put in needs to be positive, but it could give you a negative number. So if I have log base 10 of 0.0001, that's going to be a negative number. Does that make sense? All right. XX underscore 1140. Thanks for the follow. All right. Okay, any questions? Let me see. You guys have any questions? Jason Raider, what's up, dog? What's going on, man? Jackson Raider. Thanks, appreciate it, no problem. Any questions, guys? All right. All right, I don't see any questions. Do you guys understand? 5. Okay, so who say 5? No, so what you do here is multiply 4 times the 8. That'll give you 32. 4 times 8. That'll give you 32. So you remember that property. That's what we're using here. Log base A of x plus log base A of y is equal to log base A of xy. So log base 2 of 4, log base 2 of 8, and log base 2 of 4 times 8. And that's what those properties are. There are other ones. And I think those are the sample ones. So if you had, one minus the other one, you divide one by the other. So I think this is it for log. Any questions before we move on to something else? I think we can do one more topic. Somebody talk about sine and cosine. We'll do some of that, and then we'll move on to something. We'll probably call it a day. All right, so any question? The answer is 5. I'm not saying this is equal to 32. I'm saying this right here is 32. 4 times 8 is 32. Who? You lit the class? That's terrible. Hey, welcome. Nobody late here. Extrando. I probably messed up your name. All right, so no problem. All right, I don't see any questions. Let's move on to some trig. I'll do this pretty fast, and I know you guys have been asking about that. So think about if you have a triangle. And you can do that in the unit circle too. So you have a triangle here. This is the right angle. Let me stop being sloppy and do a better triangle. So it's small trig stuff. So angle here, alpha. So let's say this angle here is alpha, or theta. So, and one of the things to remember is SOHCAHTOA. So sine is equal to opposite over hypotenuse. So the sine of theta. And all of those are in reference to this angle theta. So if you considering this angle, the opposite side is going to be this, not this. So when we say opposite is opposite in reference to the angle theta. Okay, yeah, 32 Mira _20, yes. SAT prep. I have some on the YouTube channel, Mira, but I can do some more stuff because I've seen people doing it. I don't know if I'll be able to do them today, but this could be an SAT questions. If I had them in front of me, I could. But next Tuesday, I'll make sure to bring some. If you have questions, all of you guys always text them to 904-299-8417. So what I do is I check those before I go live, and I go, these questions, that's where I got them from. So any questions that I had from there, I put them on the board and I start with them. So yeah, text all of your questions. Just take a picture of it, whatever you're working on, take a picture of it, send it to this, and it's easy. And then when I'm going live, I'll tell you I'm going live, and then you can go. No problem, Mira. No problem. Anybody can do it. All right, cool. So trig. So now we have sine. So sine, according to SOHCAHTOA, sine is opposite over hypotenuse. The hypotenuse is the longest side, and then the opposite to this angle is this. So let's say I call this, A, B, C. Okay, the sine is going to be AB divided by BC. So whatever was here, the opposite side, divided by the hypotenuse. The cosine of theta, of angle theta, is going to be, cosine is adjacent over hypotenuse. So cosine is going to be the adjacent. Adjacent in respect to the angle. The angle theta here, what's adjacent to it is next to. Next to it is AC. AC divided by the hypotenuse BC. Tangent of theta, so tangent is opposite over adjacent. So tangent of theta is the opposite side. What's the opposite side in relation to this? AB divided by the adjacent side is tangent of theta. Opposite side divided by the adjacent side is AC. AB divided by AC. Now, if we're going a little bit further, you have some other formulas like cotangent. So the cotangent is the inverse of the tangent. The cotangent of theta is what? Cotangent of theta is what? This is the inverse of the tangent. So whatever the tangent is, you flip it. It's going to be AC. It's going to be AC divided by AB. So whatever this was, the tangent was, you flip it. From those three, you can find anything. Secant and cosecant. So it's the same thing, you know. Cosecant is the inverse of sine backwards, and then the secant is the inverse of cosine. So the cosecant is the inverse of sine. So you would flip this one. So you'd have BC over AB. And then I've heard secant, which is the inverse of cosine, is going to be BC over AC. So let's just flip them. Cotangent, secant, cosecant, they just flip it in the other side. Of what you start with is knowing these three. SOHCAHTOA. So if you heard the mnemonic before, SOHCAHTOA. Sine is opposite over hypotenuse. Opposite side of the angle, AB, hypotenuse, AC. Sine is opposite over hypotenuse. Not AC, hypotenuse, BC. So, yeah, I think this is it. Any questions? Let's see. No problem. Mirror _20. Let's see. Any questions? I think we're coming up to an end, guys. Coming to an end. Any questions? Questions? All right, that's probably going to be it. All right. Okay. 31 people live. I hope I could help you guys. Let's see. I hope I was able to help y'all. Let me sit right here too so I can go on the camera for YouTube too. Thank you guys for showing up. It was a pleasure doing this for y'all. Christine Caddy. No questions. You helped so much. Thank you very much. No problem, man. Next time, if you have questions, text them to that number. I don't put this number big on the board. Text me those SAT questions, and I'll help you in them. And on that YouTube channel you on, there's about 100 ACT question, SAT math question, just math only. So you can just go in there and I solve them. So you can go in there and try them out. So text all your questions to 904-904-299-8417. And if it's something that you want me to talk about, you don't have a specific question, you want me to talk about something, let me know too. Yeah. So thank you. No problem. Leslie Aquardi, 65. Ammon 106. No problem. Let's see. Anything else? I can help you with your math homework. Daddy J 2525. Text it to 904-299-8417. This my math is way too complex for GAN V Club. If you haven't taken those classes, it's gonna be a little bit hard. Anything else? Thanks, no problem. I appreciate it. All right, so Andre Pauls. I would have to see what you're saying. Take a picture and send it to me. Anyone who got their questions answered, that's mostly how they got it. You take a picture and send it to me, and I'll be able to help you. No problem, Mira. Thanks, man. I appreciate your help. Thanks. I'm glad to help. Mira _20. Yeah. Anything else, guys, for me? Can you help with geometry? What's the number? 904-299-8417. I'll put it on here. 904-299-8417. So when you text it to me next Tuesday, I'll just go live and then I'll answer your question. So yes, Stephen Bishop 05. Actually, we did some geometry today. I don't know if you were here. But if you have a question specifically, text it to that same number. 904-299-8417. Anybody on YouTube, you guys are good? This is my first time going making this on YouTube. I didn't realize that the screen would be backwards. I felt bad for Carlos, Medina, Jack, Stank Meme, Spotify stuff, and Mirror especially. Especially, Mirror's been here the whole time, and the board was backwards. All right, so let me see. Oh, no problem, man. Yeah, text it to that number, and then next time I come live, I'll solve it. If it's something that a lot of people are asking to, I can just make a video about it, and before I come live next Tuesday. So, guys, as you know, text everything that you have to 904-299-8417. We go live every Tuesday around 10:45 p.m. So, just come by and hang out with us. Yeah, Stephen Bishop _05. I will look at it if you send me geometry. I actually like doing them. Let's see. Wildflower _queen. Hey, how you doing? Thank you. No problem. All right, guys. All right, this is it for me. I'm gonna go to bed, and I'm glad I was able to help you. Anisha Shander, thank you for helping everyone. No problem. No problem. I am rising senior is bad that I haven't taken the SAT and ACT yet. Um, I mean it's not really that bad. you could probably you could probably still take it, and if you prepare for it you could probably still score in it. If not, you can still take it, especially now that they're doing the COVID-19 stuff. So you'll have some time. Just get prepared for it and go take it. Some kids take it in 11th grade, but hey, just go. If you go and take it, you do well. It really doesn't. I guess as long as the school accept the score, it really doesn't matter when you took it. You know what I'm saying? So go in there and try to go get it. All right. Thank you guys, and I appreciate your help, and everyone who answered questions. Thank you. Special shout out to Mira _20 on YouTube, who's been here the whole time, and the screen is backwards. So I'm trying to see if I can fix that. All right. Thank you guys, and I'll see you next time. Thanks. Bye. Peace.